So let's talk about it. So solving x squared with an equal. So step number one is get a 0. So you always got to get a 0 first when you have an x squared. That's the difference between x squared and x to the first power, right? If this was just 3x, didn't have an x squared, then I wouldn't do all this fancy get a 0 factor stuff. I would just get x alone, right? No big deal. But when you have x squared, you got to do a specific plan. You got to get a 0, and then you can try to factor. Factor means like the 2 parentheses kind of thing. If it won't factor, or if you just don't feel like factoring, you can always do the quadratic formula. So if it won't factor, you don't want to factor, negative b plus or minus the square root of b squared minus 4ac all over 2a. That'll work too. Either way, it's just totally fine. So here we go. So I'm gonna grab these guys, and I'm just gonna jump them to the other side. Really, when I do that, what happens when you jump something to the other side of the equal sign? Just switch the signs, huh? If you want to be more formal about it, you could subtract 20x and subtract 32. That's what I'm really doing. I'm just saving time. So that'll end up being 3x squared minus 20x minus 32 equals 0. Good to there so far? And now we need to factor it. So let's do that. So to factor it, there's all kinds of ways. There's, some people make the, what's it called, the X pattern in the diamond. Yeah, diamond. This is called diamond method. Whatever. I don't care. Do whatever you want to do. I'll show one way. In the end, it's basically being able to FOIL backwards. That's what you're doing. You're basically guessing around and foiling until you got it right. That's all the methods in the end boil down to that. That's what you're doing. So basically, you've got to be so comfortable foiling that you can check several foils until you have it right. That's the end of the game. So I just write the word FOIL. This is my little method. And this FOIL stands for first, outer, inner, last. You might remember. So that means the first one in this parenthesis times the first one in that parenthesis, making 3x squared. That's why I did 3x and x, because they make 3x squared. And then the last one in this parenthesis times the last one in that parenthesis to make 32. What times what makes 32? 8 and 4, but also 2 and 16 and 1 and 32. Well, how do you know what you want to use? Well, it could be any of them, but usually it's the ones closer together. So when you consider 4 times 8, 2 times 16, and 1 times 32, which pair of numbers is the closest together? 4 and 8. That's usually what they pick. That's usually what they make when they make up these problems. So I'm going to go 4 and 8. I want to do it wrong at first, so I can show you. Yeah, it's 8. It's not this way. I want to show you how you know when it's wrong. So I'm going to try it this way. It won't quite work. How do you know? Is it okay if I erase this? You guys got the quad down there? Come up here. It'll be on the YouTube later if you didn't get it. Okay, so coming up here again, let's get a little more room. So 3x squared minus 20x minus 32 is 0. And then I'm going to do FOIL. So 2 parentheses. So 3x times x. And again, 8 and 4 is not right. How do you know? Well, how do you finish checking? Well, I've got front and front making front and last making last, but I got to make the middle work. How do you make the middle work? The middle comes from OI. What does OI stand for? Outer with outer, inner with inner. Right? So 8 times x is 8x. 3x times 4 is 12x. How can they make the middle term? What's the middle term? Now notice I haven't brought any pluses or minuses in till right now. The middle, the minus 20. So 8 and 12 have to somehow make minus 20. So how can they do that? Well, they both got to be minus, don't they? You got to have, if you lose $8 and you lose $12, then you lost $20. So that's right, but it's not. Let me show you. Yeah, so you move them up and go, there it is, minus 8, minus 4. But that doesn't make negative 32, because remember, they have to multiply. They add to be the middle, don't they? But they add to be negative 20. That's all good. But they do not multiply to be negative 32. Negative times negative is not negative. So although the middle's working, the back part is not working. So what does that mean? That means it's not right. So what do I do to fix it? You always trade the order on the back too. That's the first thing you trade. There is a seat up here if you want a real close one, or back there is fine too. Okay, so I'll switch them around. So what was it? 4 goes here, right? 8 goes there. Right? Yeah, that'll work, yeah. So, yeah, so I switched them. I switched the 8 and the 4. And now let's try the inner-outer thing again. No signs again, no pluses or minuses. Let's try the thing again. So the 2 inner makes 4x. The 2 outer makes 24x. Kind of in the way here. Let me move that little arc. So, there we go. 24x. Now, can they make the middle term, which is minus 20x? Yes. Now, the sign in the middle, the sign on the middle guy, the sign in the middle always is taken by the bigger. That's a real helpful rule. Did you catch that? Sign in the middle is taken by the bigger. So the bigger, and I mean the bigger among these two, which may or may not be the bigger among these two. So bigger among these two is minus 24. So if you gain $4 and lose 24, you lost 20. That's working, isn't it? Everybody see that? It's working, right? The sign in the middle goes on the bigger. 24 is bigger than 4. So the negative in the middle, negative on the bigger. So yeah, that works. Now does it work for the other part though? Move it up there. The plus, this sign always goes straight up, right? Plus 4x. And this one goes back here. Minus 8 times 3 is minus 4. Plus 4 times minus 8, does that make minus 32? Yeah, now it's all good. Everything's working. Do you see all that? So that takes practice, doesn't it? That's hard for a lot of people. What I've noticed in the pre-calc students, that's hard. You need to get good at that. You will die in calculus if you can't do that. It'll be game over. That's why it's game over for people. It's okay right now. It's all right. If you're not great at that, you got a semester, practice that, but do a million foils, maybe not a million, but do at least 150, 200 foils this semester. Get more and more comfortable. That way when you go to, because in calculus, they're everywhere. And if you struggle with factoring, you just won't be able to make it. It's things like that stop people in calculus. All right, so I'm glad to help come by office hours. Be glad to do more and more algebra. Like I've said before, that's my main thing to do here because that's the main thing that helps. All right, so now where do we go from there? What's the next step? Yeah, each one equals 0. Yeah, remember the logic there? Because two things are timesing, right? These two parentheses are timesing to equal 0. If I said, hey, I'm multiplying two things, and it's coming out 0. Well, doesn't that mean that either one could be 0 to make that true, right? Because 0 times anything would be 0. The first one's 0. Or the second one could be 0, because anything times 0 would be 0. Right? That's reasonable. So if it's saying two things are timesing to equal 0, that means the first one could be 0, or the second one could be 0. Either way, it'll be true, won't it? Because they'll multiply to be 0 if either one is 0. So move that 4 over. 3x is negative 4. Divide by 3. Move that 8 over. Positive 8. There's our two answers. They want you to type them in with a comma. So negative 4/3, comma. Either order, doesn't matter. No parentheses. It's not graphing or anything. Just those two with a comma. There's our answers. Things I can answer on that? That's the stuff I'd really like to help you with because it's all that algebra that I know is hard for people, and especially in calc. Is that coming back? You could have done the quadratic formula. I don't know if I should take time to do that too. That'd be fine if you wanted to just you get the same two answers. If you did the quadratic formula, I'm kind of hedging, maybe quick. This is what I do. I do too much stuff and I run out of time. I got to finish this section today, as you can tell by the calendar. We're supposed to finish it and more. So maybe really quick. If you did the quad, that's fine. Negative b, that'll work too. Negative b plus or minus square root of b squared minus 4. Because some people just hate factoring, and that's fine. But you do have. Well, it's not fine. You eventually need to learn to factor. You can't always do the quad. There's other cases where you have to factor. So, but in this case, you could just do the quad. So, what's the A, B, C? Do you remember from algebra? A is the first thing. B is the second thing. C is the third thing. So, negative b, negative 20. Right, because there's a negative sign in the formula, and then b itself is negative. Double negative, going to be positive, right? Plus or minus the square root of b squared minus 20 squared b squared minus 4 times a, which is 3, times c, which is minus 32. If you can you read all that? It's getting kind of cramped in there. I keep making that 3 too small. All right, all over to a. So like the double negative makes positive 20 plus or minus the square root of negative 20 squared. You just calculate 400. Now right here, negative times, that's a negative 4 effectively. Negative times positive times negative. Two negatives? Going to be positive. Just count the minus signs. Then just multiply and you calculate 4 times 3 times 32. No idea what is it? 384. Thank you. 384 all over 6. and that's 20 plus or minus, what's that, 784 all over 6. I'm hoping that's nice. I'm sure it is. Square root of 784? 28? 28 all over 6. Good so far? I need to erase up here now. I'll just leave the final answers, because that's what we're going to get. And then you kind of come up here and go, okay, what do? You do the two options. 20 plus 28 over 6, and 20 minus 28 over 6, which is 48 over 6, which is 8. It's one of our answers. And this one is minus 8 6. Reduce it, minus 4/3. There they are. So either way, by factoring or by quadratic formula, you can get those two answers on that. Is that good? Questions on all that? So practice that. Do those again and again and again. That's real important. All right. So let's do that. Okay, so x plus 3 over 9 plus x plus 3 over 5 equals 1. Oh, yeah. Okay, that's a pain, yeah. All right, so what do you do when you got fractions like that?
Get rid of them.
Get rid of them, huh? Yeah. So multiply through by the common denominator. Now, what's common denominator?
40.
Yeah, just multiply the 5 and the 9 together. 5 times 9 is 45. Right, so that's what you always do. When you got a couple of denominators, you just get them out of there. So the LCD is 5 times 9, 45. And then you just go 45 for the first fraction, 45 for the second fraction, and for the right side, right, we're going to do equal treatment, both sides, right? If they were equal before, left and right, we treat them the same. They'll be equal after. So multiply through by 45, and then cross-cancel and multiply whatever's left over, right? Remember all that from algebra? So I'll go 9 into 45 5 times, and then that leftover 5 will multiply these guys, and I'll get 5x plus 15. Try the second. Remember that? So you cross-cancel and multiply whatever's left over. Yeah, this is just first power, so it'll just be one answer. 5 into 45 9 times, and then that 9 will multiply. So I cross-cancel, multiply leftovers. 9x plus 27 is 45. Yeah, this is not x squared, notice, right? It's not an x squared, so we're not going to get two answers. We don't have to do the zero factoring quadratic formula stuff. It's just get x alone. So it's a little easier. Started you with the hardest one probably. So that's 14x for those two. 15 and 27 is that 42? And that's 45. Like that. And then it's just get x alone, huh? So then we just subtract the 42 from both sides. So we get 14x is 3. Last step, divide by 14. There it is. 3/14. Is that good? Does that make sense on that? Questions on doing all that? Remember all those fraction rules from algebra? All right. So I'll skip that. So if I'm going, I would do everything if we had time, but I just want to make sure I'm doing the hardest stuff at least with you. So let's try this one. X squared minus 2x minus 48 equals 0. Okay, try this. Another x squared, right? X squared. So you're going to you can factor if you want, or you can do the quadratic formula. Either one's fine. This is an easier factoring one because it doesn't have a number in the front. We already did the hardest one. So for the factoring would be not nearly as hard as that last one. The easier factoring ones are the ones that don't have a number in front, or really have a 1, in other words, in front. Those are way easier. The other one was a real hard factoring one. So remember, you multiply to be the back number and you add to be the middle number. So what two numbers do you know that multiply to be 48? Yeah, there's a few things. 12 times 4, 6 times 8, 3 times something, 16. There's lots of things. Which pair of numbers should we try first? 16. Yeah, remember, it's usually the pairs closer together. 6 and 8, and sure enough, that can do the 2 in the middle, huh? Yeah, you don't, it's real simple. When you do the little happy face arc, little arc things here, it's real easy because there's nothing else that multiplies with. They just stay 6 and 8. See what I mean? So the middle is just -2. So how do a 6 and an 8 make -2? Yeah, sign in the middle always goes on the bigger, right? Have you noticed that pattern? Sign in the middle always goes on the bigger guy. It's always taken by the bigger. So -8 plus 6, right? The sign in the middle is negative. The bigger gets the negative. If you gain $6 and lose 8, you lost 2, huh? That's right. And so then plus 6 minus 8. That does multiply to be -48. That's all good, huh? It's all right. It's easier factoring. So then you just set each one equal to 0 separately. Because again, the logic is if two things are timesing to be 0, either one could be 0 to make them times and be 0. So then just jump that over. You know it's just going to be opposite sign. You remember that from algebra? It just ends up switching signs. So -6 plus 8. Math Excel wants you to type it in like that, either order. Quadratic formula would have worked too. Good on that? Yep. A little better than that other one. That other one was tougher factoring. That okay? I'll flash off that. Okay, so we got x cubed plus 4x squared minus 36x minus 140, bless you, minus 144 equals 0. Okay, so, yeah, we got to factor. You can't do the quadratic because that's only for x squared. Right, we can't do the quadratic formula. We got to factor this one. It's a tough one. Anybody remember how you factor like 4 terms from algebra? Any of my algebra students in here? I'll pick on them and I expect great things from them. No, I don't see anybody. All right, nobody gets picked on. So, yeah, grouping. Good job. Who said that? That's good. I'm impressed. Yeah, grouping. Remember grouping? It's called first two, last two kind of thing. Do you remember that? That's what you do when you got 4 terms. It's pretty tricky. So, like those first two, what do they have in common? X squared. That leaves x plus 4. Is that good so far? Right, because if that x squared multiplied, it would go back, wouldn't it? You good so far with the first two? I'm not done yet, but that's just the first two. I just took out what they had in common. The first two have x squared in common. If you remultiplied, you know, x squared times x would go back to x cubed, and x squared times 4 would go back to 4x squared, right? So far, so good. Now, these two, what do they have in common? Use your calculator. Those are big numbers if you're not sure, you know, and 144 does divide by 36. So, yeah, so take out the minus 36. And then ask yourself, what works? Minus 36 times what would go back? Well, just x. And minus 36 times what? Just divide by 36 on your calculator. It's plus 4, huh? It is plus 4 and not minus 4. Because negative 36 times positive 4 will go back to negative 144. It's right, isn't it? We good with all that so far? So far, so good? Okay, now there's another trick on this one. Let me help with that trick. If you if somebody gave you this to factor, somebody gave you x squared w minus 36w. These two terms, what do they both have in common? Well, w. It'd be easy, huh? You say, well, they both got a w. No big deal. Just take out the w, and you'd be right. Just like that, right? That makes sense? Well, what if instead of a w in common, they have a little parenthesis w? I know that's weird looking. Who would ever do that? But whatever. If they did, we'd go, yeah, okay, all right, whatever. Same thing. Just take out a parenthesis w. They both have it in common. That's correct. What if instead of a parenthesis w, they had a parenthesis x plus 4? See, that's what we got. It'd be the same thing. Parenthesis x plus 4. See how that's just the big common piece that they both have, right? It just looks big and fancy, but really they both just have a common parentheses x plus 4. And whenever two big terms, right, you want to look at this as one big term, second big term. There's the separator. Whenever you get two big things separated by a plus or minus, and they both have something in common, you put that common element in the front. Just one of them, right? Just one of them. Right? When it was w and w, I did not put w squared in the front, did I? Just one w, because that one could distribute back to go back to both again, couldn't it? So that's exactly what we do here. See how it's the same thing, just bigger? So I just put the x plus 4, just one of them in the front. And then what does that leave on the inside? Whoops, not that, x squared and the minus 36. Oh, I forgot the equal 0 here. Is that good? Y'all see what I did there? That's just what they have in common. They both just had a big parentheses x plus 4, and I put it in the front. Right? You just take out what's in common, x plus 4, and you remove the common part, and you just bring down the leftovers, don't you? It's another way to see it. Okay, now, where are we going to go from here? This problem just keeps going and going. So now we have x plus 4, x squared minus 36 equals 0. What am I going to do with x squared minus 36? Yeah, remember how to factor that? X plus 6, x minus 6. So we have x plus 4, and then this guy is going to break into two things. X plus 6, x minus 6. These are arrows here. Equals 0. Like that. Okay. And then, just set each one equal to 0, huh? Because we have three things that are multiplying to equal 0. If I told you, hey guys, I'm thinking of three numbers in my head, you know, and they're multiplying to come out 0, you know that any one of them could be 0 to make them all times to be 0, huh? So that means the first one could be 0, or the second one could be 0, or the third one could be 0. Any of them could be 0 to make that make them all times to be 0. So you know, it's just when you jump to the other side, it's just going to switch the sign on all of them, huh? So it's going to be negative 4, minus 6, and plus 6. There's our three answers. Question?
I subtract 36, add 36 on both sides, and then do the square root.
That'll work too. Yeah.
Is that always true?
Yeah, but remember to put plus or minus when you do the square root. Yeah. So a good question was asked. So that's the fine answer. She was saying, hey, could I have I just stopped right here. She was saying, and I just took the minus 36 and just set that equal to 0 and solved. That's totally fine. That's a good way to work as well. So then that would be x squared equals 36 when you jump that minus over. Then you root it. But remember, when you put a root on, you got to go plus or minus. Because squared could be plus or minus 6. Squared would be 36, huh? So you'll get plus or minus 6. You get those two answers. Same. Is that good? So you do have to remember when you put a root on both sides, you got to put plus or minus to get both the answers. Good? Remember all that from algebra? Kind of. That was a hard for solving. Okay, so square root of y plus 7 is 8. Can you solve that one there? What do you do when you got a root?
Square both sides?
Yeah, 2 power both sides, right? So go ahead and 2 power both sides to get rid of that root. Give you a second there. Okay, so whenever we have a root, we 2 power. So I'm going to 2 power both sides, doing the same thing to both sides. The 2 power just tears off the root, doesn't it? Just eliminates the root. It's the opposite of it. You guys good with that? You know that that's the case. So then that'll be y plus 7, and 8 squared is 64. Like that. And then it just subtracts 7. So it's, what's that, 57? 57? We're done. Is that good? You aware that 2 powers cancel out roots? They're the same thing, right? You can prove it just with numbers. Like if you have the square root of 3 or something, and then you 2 powered it, what would that be? That would be root of 3, which is root of 9, which is plain 3. See how the effect was? It just tore off the root? That's what 2 powers always do to roots. In the end, they just eliminate them, don't they? So that's what happened here. All right, so a little review of some graphing calculator stuff. So I'm going to have to do this one somewhat rapidly. So 2 over x plus 3 plus 4 over x minus 1 is minus 5 over 3. Okay, yeah, this is a challenging one. So fractions, what do? Multiply through by the common denominator, which in this case is all the denominators. You got to use them all. So in other words, I'm gonna really run out of room. I got to make this bigger. All right, so 2 over x plus 3 plus 4 over x minus 1. Negative 5 over 3. Okay, so let's multiply through by all of it. So 3 x, that says x plus 3, x plus 3, x minus 1. 3 x plus 3, x minus 1. 3 x plus 3, x minus 1. So that's what we always do with fractions. You catching that pattern? Right, is we always just multiply through by all the denominators put together, right? Then cross-cancel and multiply whatever's left over. This is going to be a very long problem. And I don't got time for this. Again, so I'm going to kind of go quick. It'll be on YouTube. So cancel the x plus 3's and multiply whatever's left over. What's left over? Well, 3 times 2, 6, and x minus 1, which will distribute in a minute. Good for that first part? And then x minus 1's cancel. In the middle, 3 times 4, 12. And x plus 3, it'll distribute in a minute. Equals 3's cancel. And negative 5. I'm going to go ahead and FOIL these guys right now. Right here, right now, I'm going to FOIL these. So x goes to both. X squared minus x plus 3x minus 3. You guys okay with that? So the 3's canceled. The minus 5 is right here. And I FOILed these. And now I got to gather some like terms here. This will be what? Minus x plus 3x is plus 2x. The other side going to distribute 6x minus 6 plus 12x plus 36. And then we gotta distribute again. It's a long problem. Minus 5x squared minus 10x plus 15. The other side, gather like terms, 6x and 12x is 18x. Minus 6 and plus 36 is plus 30. Whew. You okay to there so far? All that multiplying and gathering like terms? Questions to there so far? Okay, you see how I multiplied all that out? Okay, so now what? What should we even be thinking about? Well, we've got x squared. When x squared rears its ugly head, when x squared shows up all of a sudden, we need to go back to those steps I gave you. Remember back here? Oops, at the beginning. Where did we first do it? Oh, I erased it. That's right, I erased it. Well, what I said first was you got to get a 0, huh? When you see x squared, remember I wrote the 3 steps. Step 1 was get a 0. So we got to get a 0. So when you see x squared rear its ugly head after you gathered like terms and everything, then you think, oh, I got to get a 0. That needs to be your next thought. I got to get a 0. Where? How? What?
Just move it over to one side.
Yeah, I would probably just grab all this stuff and just yank it over there. What? because I don't really want the front term to be negative. That's kind of a pain. So I'm going to jump him over here so he'll become positive 5x squared. Does that make sense? I jump everything to whichever side where the front term, the x squared term, will be positive. That's just easier to deal with. You don't have to. You can move it over here. It'd be fine. But it's harder to deal with the front term being negative. So jump them that way. Everybody jumps. So I got to go to a new screen here. So 18x plus 30. So we're at 18x plus 30 equals what? Minus 5x squared minus 10x. 5x squared minus 10x plus 15. Okay, so I'm going to, like I said, grab all these guys and jump them over, whoops, over there. Oh, come on. So there, and there. So what do I got? Plus 5x squared plus 10x minus 15. And then there comes the 18x and the 30. 0. I got a 0 by doing that. Gather like terms. 5x squared. 10x plus 18x is 28x. Minus 15 plus 30 is plus 15 equals 0. We good to there? Now it's either quadratic formula or factoring. I'm going to factor. I don't got time to do the quadratic. This will factor actually somewhat easily. 5x times x makes 5x squared. Last times last, I'm just going to do it quick. I know what's going to work. The 2 inner makes 3x. The 2 outer makes 25x. And they do make the middle term of plus 28x if they're both positive. Oops. So there it is. There's the factoring. So then you set each one to 0 separately, because if two things times to be 0, either one could be 0 to make that happen. And then jump it over. Divide by 5. Jump it over. Minus 5. There it is. Minus 3/5 and minus 5. There's your two answers. Yeah?
Where did you get the 18x plus 30 from again?
Combining my two.
I don't know. Oh, right, yeah, right here. Yeah, they just came right there. Oh, where'd I get it? So before that, I got that from 6x and 12x.
Okay.
Made the 18. And the minus 6 and the plus 36 made the 30. Yeah. Good. Other questions on that one? Does that make sense? That's a long one. That gives me a whole 5 minutes to do graphing calculator stuff. All right. All right. Do it later. So basically, they're giving me this question. X cubed minus 4x plus 1 equals 0. They want me to solve. I can't do that by hand. You could try factoring. It won't work. You can't do that by hand. There are methods out there. You could go. There's the quadratic formula for solving x squareds. There is a formula for solving any x cubed called the cubic formula, but we're not going to. I've never dealt with it. It's terrible. You can type into Google. You'd see it. It's awful looking. I forget which level it is, either the 4th or 5th and beyond. There actually is no formula. There's no way to do by hand. There is a way to do this one by hand. It's very hard. We're not going to do it. We're just going to use our graphing calculator. But I want you to know, part of what we want to make clear in this class is how technology works in the math science world. Why it's needed, where it's needed, and how by hand work fits with that. So let me start by saying, first off, x cubes are super hard to solve by hand. There is a formula. But starting at x to the 4ths or x to the 5ths, I never can remember which one. But at one of those and beyond, there is no formula. And not only is there no formula currently, but there never will be. Well, how can I say that? There never will be. How do you know? Maybe later they'll find one. It's actually been mathematically proven that there never could exist one. Isn't that interesting? There's a whole area of math called existence studies. And a young French man named Galois in the 1800s proved that no formula, I can't remember again, 4th or 5th and beyond, could ever be written with the way we write formulas. There's no way it could ever be done. So technology will forever be necessary It'll never stop being necessary for certain kinds of problems. They just can't be solved by hand. They never will be able to be solved by hand. So it's important to use technology. How do we use technology to do this? Well, you can use TI or Casio. What I'll do, guys, is I'll send you YouTubes to whatever email you put into, I'll spend these 5 minutes doing what I can, but it'll be much better. I'll send a YouTube that I get, and I just go onto YouTube and I just find other people who did it, and I'll just ship you a nice one that'll work for both the TI and it'll work for the Casio. If you have an HP or something like that, something more complex like that, I'd be glad to help you office hours with any of them. I'd be glad to help you office hours, or you could search for yourself with YouTube. That's what I do. If you come into office hours, I'll just search onto YouTube and follow their instructions. So here they are. Here for the TI, I know the TI one. So here's what you do. You put this in for Y1. You put the right side in for Y2. So you let Y1 equal on the TI graphing calculator. So this is the TI graphing, any TI. Let Y1 equal that. Let Y2 be the right side. So let Y1 be the left side. Let Y2 be the right side. I'll write it out and then I'll do it with our last 3 minutes on the screen on the graphing calculator. Then you hit graph. Well, actually, probably first you should check your window. Window's the big deal. Window's the big deal. Calculators do weird things with the windows. So you got to make sure you got to hit your window button and make sure your X min, your X max are set right, and that of course depends on the graph. They're all different for different graphs, and that's the painful part. So I'll tell you what works for this graph because I just did it in the last hour, so I know. Just the normal window, -10 to +10, -10 to +10, will work just fine for this particular function. And so then what you do is you hit graph. In fact, I'm already running out of room. Let me move this up. So you set your window. Let me come up here. Y1 is the left side. Y2 is the right side. And then you hit graph. And then after you graph, you hit second calc, which is a button up in the top. And it asks you first curve. And you just hit enter. It asks you second curve. And you just hit enter. And then it asks you guess, and you move close to the first, let's say the first intersection. You move close to the first intersection, and you hit enter. So there's the instructions, and I'll actually do it in just a second for you to see, and that'll be all we have time for. They're all the same. There's like 6 of these, or 7 maybe. They can all be handled the same. So you put Y1 in. Y1's the left side. Y2's the right side. Set up your window, -10, +10, -10, +10. Hit graph. Hit second calc. First curve, just hit enter when it asks those questions. Then it'll ask you guess. Move close to the first intersection and hit enter. Let me show you. Is that everybody got that copy down? On that. I'm going to flash onto this if you've got that down. Okay.
Oh, okay, I get it.
So I'm going to put into.
Zero value.
Can't see it.
So I'm going to put into. Ooh, it's big. So put into Y1. Put into Y1 x cubed. Now, do you know how to type all this in? This is the x on the TI anyway. That one that has x tau theta. It has a bunch of stuff. Just use that for your x whenever you're graphing. So x. Let me make that a little bigger. X cubed. This is the power button, the up arrow on the TI. X to the third power minus 4x plus 1. Everybody see that okay? Maybe that'll help. Oh, might make it worse. All right, so like that. And then y2 is just 0. Enter. So I put in y1, I put in y2. Okay, let me check my window. Window, see how I've got it? Don't worry about the scale and stuff. Just see how my x min is negative 10, my y min is positive 10, negative 10, positive 10 for y min, y max. I hit the window button to get that. Now, do you guys know about these graphing calculators that they really get bent out of shape if you mistake the subtraction for the negative? I wish they were a little more user-friendly, but they're not. So, actually, the Casios, I think, are a little better than the TIs. But anyway, so this is negative 10. If you accidentally put subtract 10, it'll say syntax error. So if you get syntax error, look somewhere for your minus signs where you accidentally put a subtraction instead of a negative or vice versa. This is the negative down here with the parentheses around it, different than the subtract. So that's a negative 10, positive 10, negative 10, positive 10. Okay, hit graph. A little bigger now. So there's the graph. Now, where's the other function?
It's hard to tell because it's easy
Oh,
to see.
the other function is the x-axis
Yeah.
because it's y equals 0. I kept thinking for another line. The x-axis is the y equals 0 is the x-axis. So y2 equals 0 is this flat line right here. You guys with me? Right? It's the flat line. Nice. And the color ones, it does it nice. Yeah, it's that flat line. Yeah, mine's all black. So does that make sense? So I'm looking then for these 3 intersections. This one right here, this one right there, and that one right there. The 3 places the horizontal line hits the curve. How do you find them? Hit second calc, come down to intersect. It says first curve, hit enter. Second curve, hit enter. Guess, move your little cursor over there close to the first intersection, hit enter. There's your answer, negative 2.11. That's the first answer. Then redo it. Second calc, come down to intersect again, hit enter. First curve, second curve, just hit enter, enter. Guess, go over there close to the second intersection, that one right there, hit enter. There's the second one, 0.254. I don't know how many decimal places they want, whatever they say, give it to them. And then the third one, second calc, got to redo it every time. Don't have to regraph it, but you have to go through the intersecting. First curve, second curve, enter, enter. Then move your cursor over near the third intersection point right there. Hit enter. 1.86. 1.86. So there they are. Those are the 3 answers they want. I'll send you some YouTubes. The windows are tricky. Have a good weekend, guys. So 1.3 is due on Monday.
Pick, not really sure.
Everybody got the calendars, right?
I get lots of hope.
Here they are if you didn't
I
get
mean,
one.
get there, but
Yeah. Here, maybe, because I got the first one, right, 2.11. I think.